Hello, my dear students. Welcome you all. Welcome to Unacademy. This is your DPP. And previously, we have completed the problems on number systems. Now, we are going to discuss about the problems on combinational circuits. So, fine. So, let's continue our discussions. And before this, we have one great announcement to all of you. That is, so the great offer is waiting for you, fellows. That is, unlock flat 50% of discounts. To avail this offer, you can use the code of BV80. Use the code of BV80 to avail these great opportunities. Avail this great opportunity, and this offer which is valid up to 12th of September only. So try to utilize this opportunity before it going to expire, and you will have a great learning experience from the top educators. So chalo, let's start our discussions, everybody. Now these are the new batches we are starting. You can have a look at now here. And so I'm started the EMT have started. So you can have a look at now here. There you can get the, so each and everything will be discussed in a very in detailed manner. You can see the top educators team are in single frame में आपको मिलेगा. To enroll to join this Unacademy, you can use my activation code, that is BV80. Use the activation code BV80 and you have a great learning experience from the top educators. Chalo, let's start our discussions. And the other new batches we are starting for EC के लिए भी हमने शुरू किया. And these are the list of books for electrical के लिए. So these are the books will be delivered to your home address within 15 days. Of course, these books are only for what, tell me? Iconic subscription students only. These are the list of books. Have a look at now. All these electrical books will be delivered to your home address within 15 days. And these are the list of books for ECE के लिए. Have a look at now. EDC, networks, electromagnetics, analog, control systems, signals and systems, communications, digital, maths and aptitude. Right. And so try to join the Unacademy as soon as possible to get a great learning experience from the top educators. And to join, you can use the activation code of BV80 to get the personalized guidance from me and great learning experience. And these are the top ranks under 10. So 16 plus ranks from the under 10 in GATE 2024. Right. Chalo, let's start our discussions. Look at now. Here, take this problem, everybody. And they has given the logical expression of the output of a 4x1 multiplexer. 4x1 multiplexer output they ask him to find. Here, tell me now here, 4x1 multiplexer. We have, this is 4x1 mux now. 4x1 mux. Now you can have a look at now here. This expression y. So this black is, you like the black color or not? Shall I use the white color? Is white पसंद है कि नहीं? White तो अच्छा नहीं ना? So ठीक है. So here we use yellow हम choose करेगा. ठीक है. Yellow के लिए बोलिए ना इधर. So this expression y, is this yellow is clear? Yellow अच्छा नहीं? So blue अच्छा है ना? ठीक है. Right. So you can see now the expression y is equal to what I can say? Y is equal to, so which this is a bar b bar into 1 plus what, tell me? A bar b into 0 plus a b bar into 1 plus AB into 0. So finally what I'll get to tell me? A bar B bar plus this term 0 na, that is AB bar. So that means finally हमको क्या मिलेगा? This is A bar plus A into B bar na. So A plus A bar which is equal to 1. So that is answer is what? Tell me? B bar मिलेगा. So option B. Next. The number of 4x1 multiplexers required to implement 128x1 mux. So here ये तो बहुत आसान है ना, division rule. So you can tell me now here 128 by 4 कितना आएगा here? That is 32. Yes, 32 by 4. Simple division. It will be 8. 8 by 4 will come to be a 2. That is 2 by 4. This will come to be a 0.5 but should be considered as a 1. So total कितना मिलेगा इधर? 43. ठीक है, 43. So required. So you can see now here in this, which will be now here, I can say this is in which level now? This is a level 1 में होना पड़ेगा. And this is in level 2. Level 2 में, and this is in level 3 में, and this is in level 4 में होगा. Now from this we can say these things as so this is agar if I want this thing, the expression which I want to implement, this is how many selection line? 2 power 7. A, B, C, D, E, F, and then this is 𝐂𝐤𝐴. You can see now level 4, this is only 1, that is 2x1 mux sufficient. So that means how many selection lines required? Only one selection line. So here this level 4 में MSB connect करना पड़ेगा. MSB means what will connect now? A will connect. And level 3 में what I can connect now here? A gone. So this और क्या बचा इधर? BC will be connected here. BC gone. अभी इधर क्या connect करना पड़ेगा? That is D and E should be connected. So D, E gone. Next, what should be connected? The level 1, that is F and G should be connected. ठीक है? So अगर, so here this answer option है तो, so what we can say now here, this is so we required 43 4x1 mux required. 43 4x1 mux required. This is one possibility. Or what else we can say here? 42 4x1 mux plus 1 2x1 mux required. Okay, these are the requirement. So options, according to options, we can choose the things. Next one. Yeah, you can tell me now here. Now, they given this multiplexer, so we need the output, we need to identify. So tell me now output के लिए क्या करूँ इधर? So this output we have to calculate now here. So you can tell me now here. So output, the expressions based upon the output, we can decide what will be the expressions. So you can see now P, what I will get the P value, tell me. P, that is X comma Y comma Z, which is given as, here we have what, tell me now X, this is what, tell me now X bar, this is X bar, and this is X only. And S1 is connected to the Y and S0 is connected to the Z. So tell me the expression here, what I can say, Y bar Z bar into X plus Y bar Z into X bar plus YZ bar into X bar plus YZ into X. Right. Now this arrange them in order. So this is order given as X, Y, Z ना. So ये order में हम analysis करना पड़ेगा. इसलिए arrange them here. X, Y bar, Z bar plus what? X bar, Y bar, Z plus X bar, Y, Z bar plus X, Y, Z. Yes, अगर आपने ध्यान से देखा तो ये इसका numbers you can tell me. So this value, this is 1, 0, 0, 0, 0, 1. So this is 0, 1, 0, 1, 1, 1. So from this we can say the things now here. So this will come to be A. So this is P of X comma Y comma Z. This will be come to be A. Tell me the minterms here. Emma. So this minterm, this is 4. 1 is there. 2 is there. 4 is there. And 7 is there. This 1, 2, 4, 7 hai na. The 1, 2, 4, 7 is nothing but what? Tell me now here. XR. That is 3 input XR gate now here. So from this, which we can say it might be a sum or it may be a difference होगा. Both is sum के लिए difference के लिए expression तो same है ना. So इसलिए we cannot decide what will be the option here, either full subtractor या full adder. Right. So अभी तो क्या करना पड़ेगा? We need to find the दूसरा expression भी find out करना पड़ेगा. So here this is what? Tell me X. This is also X only na. Here also connected. This also connected as what? Tell me X only. This is 1. This is 0. Now you tell me now what is a Q expression? You tell me that is X comma Y comma Z, and which is equal to what? Tell me. This is Y bar Z bar into 0 plus Y bar Z into X plus Y Z bar into X plus Y Z into 1. So yeah, tell me now this expression X comma Y comma Z, which is equal to, this is 0. Next one is X Y bar Z plus X Y Z bar, and this is what? Tell me Y Z. Yeah, you can tell me now this minterms are here. So क्या आएगा? This is 1, 0, 1, 1, 1, 0. This is what I can say 0, 1, 1, 1, 0, 0. So you can tell me the minterms here. अभी इधर क्या minterms आएगा? You can see. So this minterms come to be a what? To tell me. So we have a 3 is there. 3, 5. One second. This is what? This is 1, 1. So this is 3, 5, 6, 7 is there, isn't it? 3, 5, 6, 7. This is what expression now here? Borrow expression or carry expression? So this is what? Tell me now here. This is nothing but carry expression now. So from this we can conclude this as what? Tell me now. Someone carry is there. So from this we can conclude this is nothing but what circuit? You tell me. Full adder circuit. We can conclude this as what? Tell me now. Full adder circuit we can conclude now. Right. Next one. Yeah, tell me now here the number of 2x1 multiplexers required to implement of subtractor. Of subtractor implementation के लिए what we required. So you can see now here I have taken how many 2x1 mux now here. So this is one 2x1 mux we have taken. This is a 2x1 mux. It has two inputs 0, 1. Here we have selection line and this is the output. Now, so here, now we need to implement of subtractor. Tell me now, first of all, of subtractor के लिए we required the difference and borrow. Difference expression D, which is given as what? Tell me now here, A XOR B. A XOR B का मतलब is what? Tell me. That is A bar B plus A B bar. And borrow expression you tell me now, that is nothing but A bar B. So here subtractor means we are doing the A minus B, assuming that. By default we can take it as A minus B. Right. So now we need to implement this expression. इसके लिए first I am taking the terminals. Yeah, terminals you tell me now. I am taking this as a we have connected. This I connected to 0. So then what I will get to tell me now here? So will come this output as what? Tell me now here. Here I am giving A given. So what I will get the expression here? Output is a, this is A bar into B mila. So that is a borrow. Next, what else we require to tell me now here? Abhi humko, I am taking the one more expression I am taking. I am taking the one more mux I am taking like this. And this is also a 2x1 mux. This is also a 2x1 mux we have taken. And this is the selection line. And here also we'll have it, two inputs are there. This is one output. Now I am connecting here. Here I am giving this as a connected here. And here I am giving this connection I am giving here. If I given this is B. Now, so can you tell me now what I will get this expression Y? Either output क्या मिलेगा? You tell me now here. This is A bar B here. So you can tell me now this is B bar into A plus what? B into A bar B. So the expression will become as what? Tell me now here, A B bar plus A bar B. So this is nothing but difference expression only in a XOR gate we got. Now we require the borrow. And borrow, we have got this borrow here only is available now. This is directly we can take the borrow here. And the difference. So here how many marks required? You tell me now here. केवल 2 marks से काम हो जाएगा. Only 2 marks are enough. Next. If the logic expression of the output in the circuit shown in the figure A and B are same, then select the correct combination of signals. Yeah, you tell me now here. So this XOR gate, what is the output we require? You tell me. Y. Y we required as what here? This is A XOR B and XOR with C. So this is nothing but we know these minterms now. What are the minterms required? 1, 2, 4, 7 XOR gate का minterms हमको क्या चाहिए ना? Right. So then let's see how we can implement now here. For this, we can use our Maha technique. We will go for our Maha techniques. Madanaina Maha technique. And what is Maha technique? You tell me. There we can take the terminals. So we will take the terminals as like this. Here you can tell me now here. So which is so connected now C connected. C का weight कितना? So we have A, B, C. So C weight is 2 power 0, B weight is 2 power 1, A weight is 2 square. So C weight is how much? 2 power 0 means 1. So means what I can say, tell me now, this is 0 comma 1. Next here this is 2 comma 3. Next this is 3 comma 4. And this is why 3 here? 3 already came now. 4 comma 5 here. This is what tell me 4 comma 5 and this is 6 comma 7. Now you can see now what has to be connected we need to see. Now tell me now here C. Here in this thing first in 0 and 1 what we require now 1 required. 1 is a upper bound now. So इसीलिए क्या करूँ here C connected here. In this 2 and 3 what we required now here 2 required. 2 is a lower bound, that's why we will connect here. C bar will be connected now. 4 5 में हमको क्या चाहिए 4 चाहिए, that is lower bound is required, that's why C bar. 6 7 में 7 required, 7 is upper bound, that's why C connected. So now check this option now here. कौन सा option है इधर? So this what the option you can tell me? Option C. Done. Next one. A combinational circuit using 4x1 mux is shown in figure. The output is right. So you can tell me this output now Z. So first of all, so Z is equal to what you tell me? That is a Y plus here is what tell me now Y plus B ka whole bar. This is a NOR gate now. And this is a NOR gate. Now, first of all, Y. So that means what I can say now, Z. It should be given as De Morgan's law. This is Y bar into B bar. Right. So from this, Z is equal to what we can say now, Y. Y is given as what you tell me now. This is 1 to minterm. So obviously this we can say directly XOR gate now. So even if we can expand this thing, what will come here? This is nothing but 1 and 2 minterms are XOR gate only now. So this is Y value will come to be a XOR. Then what about this Y bar you tell me? Y bar means A XOR B whole bar. So that means Y bar means which is nothing but A XOR B now. So that means Y bar which is equal to A XOR B which is given as what tell me now A bar B bar plus what AB. So you can tell me now Y bar will come to be a what tell me A bar B bar plus AB into what tell me now here B bar. आएगा ना? Oh, 1 second. Here this is what tell me now B bar na. Here this is what now B bar, isn't it? So that means here this is Y plus B bar whole bar. So that's why here this bar won't be na. So this is what element of B, this also B only. So if we multiply this thing, what will come? The Z is equal to what? Tell me now. AB will come. So कौन सा option now? Tell me C. And the option is what? C. Next. Consider the circuit shown in the figure. In this case, they are asking to find the what will be the output in this XOR gate. Now, tell me now here. Here, you can observe here what they has connected here. Here, this is connected to X. This is also X only. And this is Y connected. And here they connected, this is Y bar. And this is also Y bar. And this is connected as a Z, right? And this is Z bar. Here, this is what? Z bar. Okay. Now let's see the things now here. What will be the output will come. Now, yeah, the expression we need to get it now. Look at now carefully. So this is f of x comma y comma z, which is equal to what we can say now here. And now this is, these are A1, A0 are the selection lines. So means what we can say, this is A1 bar, A0 bar into X plus A1 bar, A0 into X plus A1, A0 bar into Y plus A1, A0 into Y bar. Okay. The whole thing is into what we have. Tell me now. Enable is there now. Multiplied by enable. And so you can see now here the given A1 is given as what? Tell me now. Y bar. A0 is given as what? Z. And the enable is what? Which is a Z bar. Now you can tell me now what I'll get. F of x comma y comma z, that is equal to, see what I will get now here. And this is, so you can see now here, if I combine these two here, see what I will get now here. This is nothing but A1 bar into X, and so shall we combine any of this thing? कोई फायदा है क्या? I think there is no use of it. So fine, we can write as it is. A1 A0 bar into Y plus A1 A0 into Y bar into enable. So this is into enable hai na? So what I can write now, this is A1 bar, sorry, we can replace now. A1 is what? A1 is Y bar. A1 bar means Y na, Y into X, and A1 is Y bar, A0 bar is Z and Y, plus A1 is Y bar, A0 is Z, this is Y bar, and enable bar is what element of Z bar. Here you can see now Y into Y bar is 0. So Z into Z bar is 0. So that's why it will come to be a Y X Z bar remaining terms are zeros ना. So finally हमको क्या मिलेगा? That is f of x comma y comma z, which will come to be a x y z bar. Is this point clear to everybody? X y z bar will come. Option B. Next one. Identify the circuit. They are asking what will be the circuit they are asking. So we can talk about the nature of the circuit based upon what you tell me. So based upon the input output relation we'll talk now. इसलिए we have taken some input output. Let's analyze it. Input on outputs we'll see. Now you can see now here inputs. Let's say the input we have taken as x2, x1, x0, y2, y1, y0. So now you can tell me now this thing, what will come from these relations. You can talk about the inputs now. I'm taking the input as 0, 0, 0 we have taken. So this is the decoder we have taken 0, 0, 0 we have taken. Then what happens now here? So the decoder only this output is 1, baki 0 hoga na, all these values will become 0. All these values will become 0. So that means this is 1, remaining all values are zeros. So what I will get the output corresponding to when OP, IP, this value equal to 0 now corresponding to this one, 0 input is 1. Only this corresponding to this will come it as what tell me now 0, 0, 0 will come. Understood the working of this encoder? When I give the 0, 0, 1 as an input when I given, so see the things now what happens now here in this case, kya hoga you tell me? So this output is 1, remaining all are 0. So here this is connected to here. So corresponding to 1 will come now. 1 means 0, 0, 1, 0, 0, 1 will come. If I given 0, 1, 0, so what happens now here? अगर 0, 1, 0 दिया तो क्या आएगा आउटपुट यू टेल मी नाउ हियर 0, 1, 0. Here this value is 1. So this is connected to here. You see here connected now. That means whose input is 1? 3 is 1. So corresponding to 3 will come the output. That has what tell me now 0, 1, 1 will come. Next, when I given this as a 0, 1, 1, 3 we have given. So you tell me now what I will get this output now here 3. This is 1. This is connected to here now. So means will come the output as a 0, 1, 0. So with this we can able to conclude something. अगर आपने if I given this value 0, 1, 0, if I say this is in binary form में दिया, so can I convert this into a gray code में? What is the gray code of this thing? First MSB as it is we can write now. XOR between these two is 1. XOR between these two is 1. So this is the gray code for the corresponding given binary number. So E I हमको you can see now this thing. अगर if I given 0, 1, 1 is given, this is the binary form में दिया. So tell me now corresponding gray for this thing. So 0, XOR between these two is 1, XOR between these two is 0. This is a gray code now. So exactly we have the same thing now. So from this can you conclude now here? This is nothing but binary to gray code converter. Right. So you can take some more examples to identify the things. Next one. The expression for y is, yeah, you can tell me now here, y. It should be given as S1 bar into S0 bar into C plus S1 bar S0 into C plus S1 S0 bar into C bar plus S1 S0 into C. By combining these two, so तो क्या मिलेगा? You can check now here. So then y, which will come to be a by combining these two here. If I take S1 bar as a common, so it will come to be a. So this is what, tell me now here. We'll take it out. What, tell me now? S1 C also common. So this is S0 bar plus S0 will be now. Now in these two, I'm taking it as a S1 this also C bar. Now S1 C bar. So then it will come to be a what element of here? S0 bar plus S0. So finally it will come to be a what element of here? S1 bar C and S1 into C bar. So that is given as what element? S1 XR with C now. Where S1 is the sum. Sum is equal to what element now? A XR B. So from this we can write this as what element? A XR B XR with C. So finally it will come to be a what we can say, tell me now. Yes, it will satisfy associative property now. So that's why 3 input XR banega. So what's the option, tell me? Yeah. Next. Consider the following statements. Decoder converts binary to decimal. Yes, this statement is correct only. Decoder converts binary to decimal. Yes, correct only. Multiplexer is also called data distributor. No, multiplexer is called as a data selector. Multiplexer is called as what, tell me? Mux is a data selector. Mux is a data selector. And demux is a data distributor. Okay. So that's why this is wrong. And encoder converts decimal to binary. Yes, this is also correct only now. So 1 and 3 are correct. So the option is what, tell me now? D. Right. Fine. Yeah. That's for this sessions, and we'll continue the remaining problems in the coming session. And do follow this course, and we'll discuss each and every problem will be completed. Earlier we have seen the number systems. Next we'll see the combinational. Now thereafter we can see sequential and data converters also will be covered. Okay then. Yeah, that's for this session, and we'll meet in the next session. See you. Bye bye.